All right, so the next thing we're looking at is the determinant of a 3x3 matrix. So here we have A, which is a 3x3 matrix, 3 rows and 3 columns. So the determinant of A would be the first element in the first row, first column, multiply. So in other words, this is how you do it. It's this element multiply by the determinant of the elements, which are, if you block all the elements within the column and the row that A11 is in, it would be A11 multiplied by the determinant of the 4 elements which are not in the same row and the same column as A. So that is the first part of it. Then A12, minus A12, and then you're going to take out these elements, multiply by the determinant of the elements which are not in the same row and column as A12, plus A13 and you block out these elements and you multiply by the column, the determinant of the columns and, the elements which are not in the same column or row as A13. All right, now if that is confusing, we could use letters. And so if A is the 3x matrix A, B, C, D, E, F, G, H, I, the determinant of A, you would, it would be, the determinant of A would be A, block B, B, C, and D, G. All right, so and so on and so forth. Let's show it in action. Example 23. The determinant of A it's going to be equal to 1. So you block these elements, you took the 1 and you block the rest of the elements, multiply by the determinant of 1, 4, 1, 2, minus. So that minus is sort of like part of the formula. So it's minus 2, which is the second element in the top row. And then you block these elements. And then, so it's times the determinant of 0, 2, 4, 2. Then lastly, plus. So the signs are literally part of the formula of the thing, plus 3, which is the third element in the top row, and you block those, and you get what? 0, 1, 2, 1. Now let's find the determinant. The determinant of A would be 1, 2, minus 4. A negative times a negative is a positive 2. 0 times 2 is 0. Minus 4 2's, 8. Plus 3. 0 times 1 is 0. Minus 1 times 2 is 2. So the answer here is 1 times minus 2 plus 2 times minus 8 plus 3 times minus 2, minus 2, minus 16, minus 6. The determinant is minus 24. All right, so example 24, let's find the determinant. In example 24, the determinant of A, is equal to 3. The determinant of 1, 0, 2, 7 minus 1, the determinant of 4, 2, 0, 7 plus 1, the determinant of 4, 1, 2, 2. So this becomes 3. 1 times 7 is 7, minus 0 times 2, 0. Minus 1, 4 times 7 is 28, minus 0 times 2 is 0. Plus 1, 4 2s are 8, minus 1 times 2, 2. This becomes 3 times 7, 21, minus 1 times 28, minus 28. And 1 times 6, which is 6. So this is 27 minus 28. This is minus 1. In 25, the determinant of B is equal to 1. The determinant of 1, 1, minus 1, minus 4. Minus 1, the determinant of 2, 3, minus 1, minus 4. Plus 2 times the determinant of 2, 3, 1, 1. So this becomes 1 minus 4 minus 1. A negative times a negative is a positive 1 minus 8 minus 3 plus 2 minus 3. This is 1 minus 3. What goes in that bracket? Minus 1. So it's 1 minus 4 plus 1 is minus 3. So it's 1 minus 3 plus 1 minus 5 plus 2 times minus 1. So this looks like minus 3 minus 5 minus 2, which is minus 10. Properties of a determinant, some of this is important. So it's good to note these things sometimes. Now, property number 1 says properties of a determinant of determinants. Property number 1 says if every element of a row or column of a matrix is 0, then the determinant is 0. So if there is a row or a column in which all the elements are 0, the determinant is going to be 0. Now, if A is a square matrix, the determinant of the transpose is equal to the determinant of A. Let's say it again. If A is a square matrix, then the determinant of A transpose is going to be equal to the determinant of A. If two rows or two columns of A are identical, then the determinant of A is going to be 0. So this one is important. I'm sure this is going to come back. So we want to ensure that we remember it. That if two rows or two columns of A are identical, then the determinant of A is going to be equal to 0. If two rows or two columns of a matrix are interchanged, if two rows or two columns of a matrix are interchanged, the sign of the value of the determinant is changed. Let K be an element of the set of real number, then the determinant of Ka is equal to K to the n times the determinant of A, where A is an n by n matrix. Interesting stuff. For any two matrices A and B conformable to matrix multiplication, the mod of AB is equal to the mod of A. Sorry, the determinant of AB is equal to the determinant of A times the determinant of B. For exercise 16A, your homework is all of the odd numbers.